So a spring mass system.
I think I'd explain you spring mass system, then simple pendulum, then oscillating body and fluid, these different terms. So we have to start the last part of that chapter, that is different types of oscillation. Hamza, am I right? Okay. So next is oscillation. On the basis of medium of surrounding, we may define oscillation in two different parts. One is undamped oscillation, and next is damped oscillation. So what do you mean by undamped oscillation and damped oscillation? Suppose a spring mass system is placed in a surrounding in which there is no any viscous medium. So if you stretch it a little bit down or up, it will experience only spring force. So total force acting on this spring will be minus of ky. So if you simplify this particular expression, you will get acceleration plus k by m times y is equals to 0. So on solving this expression, you will get pi is equals to a times sine omega t. It means oscillation of a body which having constant amplitude is called undamped oscillation. Hiba, is it clear?
Yes, sir.
So if you plot a graph related to this part, it will be like this. So amplitude of oscillating body will be constant in this part. If a body is oscillating in non-viscous medium, so that its amplitude remains same. That is called undamped oscillation. Next, suppose a bob attached with a spring is placed in any viscous medium like liquid, gas. So this medium also opposes this particular oscillation. So net force experienced by this particular object in this medium will be, one of the force will be due to viscous medium and it will be minus of B times of B, and second due to spring minus of K into Y. I had explained you in mechanical properties of fluid. According to Stoke's law, viscous force experienced by any object when it is projected in that medium is equals to 6 pi eta r times b. So other than this velocity, rest of the whole term is constant. We may write it as b times v. And since this force is opposing in nature, that's why it will have negative sign. This b is called damping factor or damping constant. That's why the net force experienced by this oscillating body will be due to viscous medium and also due to elongation or compression of spring in this part. So if you simplify it, acceleration plus b by m, we may write this velocity as dy over dt plus k by m times y is equals to 0. So this will be general equation for this damped oscillation. If you simplify this part, you will get y is equals to a naught e raised to the power minus b divided by 2m into t multiplied by cos omega dash t plus some constant phi. In this entire segment, we have to deal with only this part, which is called amplitude. So we can say A is equals to A naught e raised to the power minus b by 2m into t. It means this amplitude will exponentially decreases with change in time. So if you plot variation of this amplitude with respect to time, so graph will be like this. At t is equals to 0, amplitude will be maximum. And it decreases exponentially with time. And finally, it becomes 0. So this is variation of amplitude. Maximum value of amplitude is A naught with respect to time taken. So this is called damped oscillation. So we can say if a body is oscillating in viscous medium, so its amplitude decreases exponentially. This oscillation of body is called damped oscillation. The oscillation of body in viscous medium so that its amplitude decreases exponentially with time, then it is called damped oscillation. Hamza, any doubt?
No, sir.
Okay, just write it down. Hamza, done?
Sir, the last line.
Okay.
Done, sir.
Okay. Any doubt in this two term?
No, sir.
Now, from this last part, amplitude, you will be asked to calculate time taken to change its amplitude from one point to another. So how to calculate time for changing amplitude? According to expression, A is equals to A naught e to the power b by 2m into t. Move this A naught to left side, so you'll get A by A naught equals to e to the power minus b by 2m into t. Now, if you reverse this exponent, this fraction, this negative sign will becomes positive, or you may write this particular part as 1 by e to the power plus b by 2m into t. So you will get a naught by a as exponential b by 2m into t. Taking log to both sides, so ln a naught by a, and this part on taking ln or log get cancelled out, so we're left with b by 2m into t. So time taken to go from a naught to a will be 2 times of m divided by b ln a naught divided by a. So this will be your final expression of calculation of time on changing from one point to another. Let me define you a question related to this part. A body of mass 200 gram is oscillating in viscous medium having damping constant 40 gram per second. Find time to change amplitude to fall its amplitude to half of its initial. It means final A is A naught by 2. Mass is given, damping constant B is also given. Just substitute all the values and use ln2 as 0.7. Try to find. First, try to down and try to solve this part. Hamza, you got any answer?
No, sir, doing it.
Okay. Khalid, you got any answer?
Yes, sir.
Just send me. According to the formula, T is equals to 2 times of M divided by B, ln A naught divided by A. So 2 times of mass, we have 200 gram divided by B, 40 gram per second. So both are in same unit. So keep it as it is. So 0 and 0 will cancel out. 2 into 20, 40 divided by 4, it will be 10. ln A naught as it is, and A is A naught by 2. So you'll get 40 by 4, 10, multiplied by A naught cancel out, ln 2, and ln 2 we have 0.7. So you're left with 7 seconds. That is time taken by this wave to fall its amplitude from A naught to A will be 7 seconds. Hiba, is it clear?
Yes, sir.
Okay. Salman, any doubt?
No, sir, no doubt.
Okay. Okay, so this is all about this entire chapter, oscillation or SHM. So let's start with new chapter, that is wave. First, what do you mean by wave? Suppose you have a ball initially at this point. So if you give it this particular ball any energy, or if you have done any work on this particular object, it may get displaced from this point to some new point. It means on giving energy to this particular object, it themselves displaced from one point to another, carrying out that energy or momentum from one point to another. But suppose in case of any string, let's say this is string. If you hit this particular string at any one point, let's say along this direction, a disturbance will be created like this, which may propagate along this medium like this. So this is disturbance created on this particular string by hitting or giving it some energy along this direction. So in this case, this disturbance will propagate from one point to another, but the particle which is present at this point, this point, this point will remain same at its original position. There is no any displacement of particle from one point to another point, but in this phenomena, energy and momentum is going from one point to another. So this is called wave. So wave we can define, it is a phenomena of transferring of energy and momentum from one point to another without displacement of matter particle. Hamza, is it clear?
Yes, sir.
So you can say it is the phenomena of transfer of energy and momentum from one point to another without the displacement of matter particle. Now we may define this wave on the basis of propagation or medium into three different categories. One is electromagnetic, a wave which can travel even through vacuum. Next is mechanical wave, a wave which requires any medium for its propagation. And third, matter wave, wave associated with matter particle. So in this part, no need of medium. So you'll say electromagnetic wave is produced due to accelerating charge, or you can say due to oscillating some variable electric field and magnetic field. You may learn more about it in next year, that is in class 12. Mechanical wave, a wave which require any medium for its propagation. Require any medium for its propagation. And third, matter wave, wave associated with matter particle. That is electron, proton, neutron, positron, alpha particle. These different particles have dual characteristic, both as particle as well as wave, defined by de Broglie hypothesis. You'll learn more about it in next year also. So in this chapter, we have to define only mechanical wave. Just write it down to this part. Hiba, done?
Yes, sir.
So next is mechanical wave. You will say a wave which requires any medium for its propagation is called mechanical wave. So there should be some property of medium for propagation of this mechanical wave through it. So property of medium for propagation of mechanical wave. First is medium should offer some elastic behavior. It means medium should be elastic in nature. This elastic behavior we may define in three different types: elasticity along length, elasticity along shape, and compressibility or incompressibility. These two terms is defined only for solids, but this is defined for whole different medium. For solids, and this is for all different medium. Next is medium should be inertial. It means it should have some mass so that it will have tendency to store or withhold energy with it. To hold energy. So another question will be, which medium is non-inertial? So you'll say vacuum. That's why mechanical wave can't propagate through vacuum. Hamza, is it clear?
Yes, sir.
Third, medium should offer least friction or opposition. So there will be least energy loss while propagating from one point to another. So these are different property of medium required for propagation of mechanical wave through it. Just write it down.
Sir, by the way, what did you write there? Medium should be inertial.
Inertial. It means it having some mass so that it will have tendency to hold energy. Okay, Khalid? Hiba, done?
Yes, sir.
Okay. Next is types of mechanical wave. Suppose you have any soft spring. You may hit this particular spring two different ways. In first part, if we hit this particular spring along this direction, so this spring may deform like this. And so on. In this part, this is a region of high density and low volume. Density high and volume low. This is called a rarefaction, compression. This is region of low density and high volume. This is called rarefaction. In this part, particle is vibrating to and fro, and direction of propagation of wave is also along same direction. So this is a vibration of particle, and this is direction of propagation of wave, and both are along same direction, so it is called longitudinal wave. Hiba, is it clear?
Yes, sir.
In second part, if you hit this particular spring along this direction, it may create like this. So this topmost point behaving as hill is called crest. This bottom point behaving as valley is called trough. In this part, particle is vibrating up and down, and propagation of wave is perpendicular to it. This is vibration of particle, and this is propagation of wave. Both are along perpendicular to each other, so it is called transverse wave. Salman, any doubt?
No, sir.
Okay, just write it down. Hamza, done?
Yes, sir. Done.
Okay. Next, we have to explain these two different waves individually. And further, we have to calculate velocity related to those different waves. So first is transverse wave. It is a wave in which a vibration of particle is perpendicular to the direction of propagation of wave. Next, we have to calculate velocity of transverse wave on a string. You'll be given, suppose, if velocity of transverse wave depends upon tension in string T and linear mass density mu. So using these two parts, we have to calculate expression of velocity. So according to the concept of dimension analysis, we may write velocity is equals to some constant proportionality k and its depending factor tension raised to x, linear mass density mu raised to y. Now, you may write dimension of each quantity along right side and left side. So in left hand side, we have velocity, whose dimension will be mlt raised to -1 is equals to k, which is proportionality constant, t, tension having dimension of force, so it will be mlt minus 2 raised to x. Mu is linear mass density, mass per unit length raised to y. So on solving, you will get m raised to x and m raised to y from this part, L raised to x and L raised to minus from this part, and t raised to minus of 2x. Khalid, is it clear?
Yes, sir.
What will you do next in this part to calculate the value of x and y? Hamza, how will you calculate
Sir,
the value? Yes, Khalid,
no, I was gonna say the answer.
just tell me.
We will substitute the exponents.
Good. On comparing the exponent on either side for the same expression, according to principle of homogeneity, you will get the value of x and y. Just write it down and try to solve x and y. Hamza, just tell me the value of X and Y. Khalid, you got any answer?
Yes, sir.
Just send me. On comparing the exponent, first for m, x plus y, in left hand side we have 0. For L, x minus y, 1, and minus of 2x is equals to minus 1. Hamza, we have to solve value of x and y. So this minus and this minus will cancel out. So you'll get x is equals to plus half. If you substitute in first expression, y is minus of x, so it will become minus half. Hamza, is it clear?
Yes, sir.
And the value of k, that is constant of proportionality, experimentally is calculated as 1. So you'll get velocity is equals to k, tension to the power x, and linear mass density to the power y. So t to the power half, move this to downward, so it will become positive half. Now t divided by mu, having common exponential half, and it will be nothing but root under t by mu is equals to velocity. So velocity of transverse wave created on string is equals to root under tension by mu. So first you may calculate tension in the string. Second, linear mass density, that is mass per unit length. On putting this in this expression, you will get velocity. Hiba, any doubt?
No, sir.
Okay, just write it down. I'm giving a problem related to this part. Hamza, done up to this part?
Yes, sir.
Okay. Suppose a string AB is connected to one side to this rigid support and the other side by any block having mass 4 kg. If mass and length of wire AB is 50 gram and 50 centimeter. Respectively. Find first linear mass density, second tension produced in the wire, third velocity of transverse wave created on it, and fourth time taken by wave to go from A to B. Just write it down and try to solve. Let me give you some hint how to solve it. First, you have to calculate mu. Mu is linear mass density, that is mass per unit length. So we have wire A to B having mass 50 gram and length 50 centimeter. So you may write mu is equals to mass divided by length. Just substitute their value. First, convert them into their SI unit. In second part, you have to calculate tension. So which source is responsible to generate or produce tension in this particular string AB? So you will say this 4 kg block. So tension will be equals to mass of block times gravity. Now in third part, you have to calculate velocity, which is nothing but root under tension by mu. Substitute the value of tension, what we have obtained in the second part, and mu from the first part, then you'll get velocity. In last part, you have to calculate time taken by wave to go from A to B. According to the formula, time is equals to distance by velocity or speed. So distance by v. Distance from A to B is given and velocity we have calculated. Just put all the values and try to simplify it. Hiba, any problem?
No, sir.
Okay. Tell me the first answer for mu. Hamza? Good. Tension? Khalid?
Yes, sir.
What will be the value of tension?
40.
Good. Just put these two different value in third part to obtain velocity of transverse wave. Mu is linear mass density, which is mass by length. Mass we have 50 gram multiplied by 10 to the power minus 3 converted into kg. Length is 50 centimeter, 10 to the power minus 2. 50 and 50 will cancel out, so you're left with 10 to the power minus 1, that is 0.1 kg per meter. Next, tension, which is equals to mass times gravity. Mass of block is 4 and gravity is 10, so you'll get 40 Newton. So if you substitute these value, so transverse will be tension by mu. Tension we have 40 and mu is 0.1 root under. So if we remove this particular decimal, then 10, so you'll get 400 root under, that is 20 meter per second. In last part, we have to calculate time taken to go from A to B. So it will be distance by velocity. A to B, distance is 0.5 meter, divide by speed, 20. So you're left with 0.5 by 10. So 5 divided by 2 will be 2.5 multiplied by 10 to the power minus 2 seconds. Hiba, is it clear?
Yes, sir.
Next is, we may transform this particular formula in some other way also. Suppose if a string is hung vertically and a block is attached to its end, so that block will responsible to generate tension in the string. So we may find, according to concept of Young's modulus, Young's modulus is equals to longitudinal stress by longitudinal strain, F times length divided by A times delta L. So force will be equals to YA divided by L multiplied by delta L. Or you may write YA delta L by L is simply strain. This force is nothing but tension produced in that string. Next, rho, which is volumetric mass density, that is mass divided by volume. So mass, volume is area of cross section to length. Mass per unit length is also called mu divided by A. So mu will be equals to rho multiplied by A. Now, if you substitute these two values in the expression of velocity, so you will get velocity of wave root under tension by linear mass density. Tension we have YA multiplied by strain divided by rho into A root under. Area and area will cancel out, so we're left with Y by rho multiplied by strain. Khalid, any doubt?
No, sir.
From this part, we can say velocity of transverse wave is depending upon Young's modulus. And as I had explained you, Young's modulus is defined only for solids. Hence, we can say transverse wave can travel through solids only. You may just write it down, then I'm defining the next part. So from this part, we can say as transverse wave depends upon elasticity and shape, that is Young's modulus, which is defined for solids only. Hence, it can travel through solids only. So you'll be asked why transverse wave can travel through solids only. So this will be our answer. Next is longitudinal wave. It is a wave in which particles oscillate or vibrate along the direction of propagation of wave is called longitudinal wave. a wave in which vibration of particle is along the direction of propagation of wave. So next, we have to calculate velocity related to this longitudinal wave. So you will be given, suppose velocity of longitudinal wave depends upon bulk modulus, beta, and volumetric mass density, rho. So using this expression, try to find expression of velocity. So according to the concept of dimension analysis, we may write velocity is equals to some k times beta raised to x and rho raised to y. So using this expression, write the dimension of each term and try to find the value of x and y. First, write it down. If you substitute the dimension of this different expression, velocity having dimension m0 L t to the power minus 1, k is proportionality constant, beta having dimension as stress or pressure. So it will be ml minus 1 t minus 2 raised to x, and density mass per unit volume raised to y. So on solving, you will get m L to the power minus x minus 3y and t to the power minus 2x. Just equate the exponent of each term, you will get the value of x and y. Hamza, you got any answer for the value of x and y? Iba? Just compare the exponent on either side. So you'll get x plus y exponent of m to be 0 minus x minus of 3y is equals to 1 exponent of L, and minus of 2x is equals to minus 1. So x is equals to 1 by 2. Now substitute this part in first expression. So y is minus of x, so it will be just minus of 1 by 2. So according to the expression, v is equals to k is proportionality constant, which is experimentally equals to 1, beta to the power x 1 by 2, and rho to the power y, which is minus 1 by 2. So you're left with beta by rho having common exponential half. So it will be root under beta divided by rho. Hamza, any doubt?
No, sir.
Now from this part, we have to calculate or transform this particular beta for some standard form. So first assumption related to this is Newton's formula of velocity of longitudinal wave or velocity of sound. So according to Newton, propagation of sound in air or in any medium will be isothermal process. So according to Newton, he assumed that propagation of sound is isothermal process. So for isothermal process, delta T equals to 0, equation of state will be P V to the is equals to constant. Since temperature is constant, so differentiate this particular part, differentiating with respect to volume. Differentiation of first part multiplied by second one plus differentiation of second part multiplied by first one, and right hand side we have constant, so its differentiation will be 0. So dp by dv will be minus of p by v from this part. Next we have to calculate bulk modulus from this expression. Now bulk modulus is minus of dp by dv multiplied by volume. dp by dv, if you substitute, so you'll get minus minus plus p divided by v multiplied by v. V and v will cancel out. So beta for isothermal process is just equals to p. First write it down, then I'm defining the next part. Hamza, down.
Yes, sir. Done.
Now, if you substitute this beta in the above expression, so you will get velocity is equals to root under P divided by rho. Now, if you have to calculate for air, pressure is 1 atm, that is 1.013 into 10 to the power 5 Pascal, and density of air is 1.293 kg per meter cube. So if you substitute these values in the above expression, velocity of sound will be 280 meter per second, according to the assumption of Newton. But in actual, velocity of sound is about 331 meter per second. But speed of sound is 331 meter per second. So we can say Newton's assumption is wrong. Hence, Newton's assumption So next, to correct this particular explanation, we may define Laplace assumption, which is called Laplace correction to the velocity of wave or longitudinal wave. According to Laplace, propagation of sound is adiabatic in nature or adiabatic process. Why? Since in sound propagation, there will be formation of compression and rarefaction, which takes place very fast or rapidly. So I'll explain you in thermodynamics, if a process is occurring or taking process very slow, almost it act as to be rest, that will be considered as isothermal. And if a process is very fast, that will be considered as adiabatic. So in this part, propagation of sound, there will be formation of compression and rarefaction very fast, so it will be treated as adiabatic in nature. He assumed that propagation of sound is adiabatic process. It means delta Q is equals to 0. Why it should be adiabatic in nature? So you will say, as in sound propagation, formation of compression and rarefaction will be fast. So there will be no enough time for exchange of heat. That's why it's considered to be adiabatic in nature. Just write it down, then undefined relation related to this process. Khalid, any doubt?
Sorry, sir, did you ask something?
Any doubt up to this part?
No, sir, no doubt.
Okay. Hiba, done?
Yes, sir.
Okay, so using this concept for adiabatic process, delta Q is equals to 0. Khalid, just tell me equation of state for this process. P V to the power gamma is equals to constant. So differentiating with respect to volume, differentiation of first part multiplied by second one plus differentiation of second part having exponential gamma, it will be n x to the power n minus 1 multiplied by second function p. Constant on differentiating will be 0. So if you rearrange this equation, dp by dv is equals to minus of gamma, v to the power gamma divided by v multiplied by p. So v to the power gamma, v to the power gamma will cancel out. So left with dp by dv is equals to minus of gamma p by v. So using this expression, beta is equals to minus of dp by dv multiplied by volume. dp by dv we have gamma times p by v multiplied by volume. Volume cancel out. So beta will be equals to gamma times p. Hamza, any doubt?
No, sir.
Now, if we substitute this value of beta, so velocity of longitudinal wave, beta by rho, so it will become gamma p divided by rho. Now, if you have to calculate for air, tell me the most abundant gas in air. Hiba, which is the most abundant gas?
Nitrogen.
Good. How much will be its percentage existence? It will be 78%. Okay. Hamza, just tell me the next most abundant gas. Khalid,
Sir, hydrogen.
hydrogen is about 0.01%. What we breathe during respiration?
Oxygen. Carbon dioxide or oxygen.
Carbon
Oh, okay,
dioxide.
Sorry, oxygen.
Oxygen is the second most abundant gas. That's why human and all living being exist on the surface of Earth. Okay. So it is about 20 or 21%. Nitrogen is also diatomic and oxygen is also diatomic. If we combine these two composition, so it will be about 98 or 99% of the whole atmosphere. So we can say most volume of atmosphere is diatomic. So we may consider this gamma to be diatomic only. So gamma will be equals to degree of freedom for diatomic will be 5. So if you substitute, you will get 7 by 5. That is 1.4. Pressure we have 1 atm and density is 1.293. So on substituting, you will get velocity is equals to 331 meter per second. Hence, it is accepted. Hiba, is it clear?
Yes, sir.
Okay, just write it down. Hamza, done?
Yes, sir, done.
So from this expression, we may write velocity is equals to root under beta by rho. You may convert this beta as gamma times p divided by rho. Next is gamma p. Rho is mass divided by volume, root under. PV is nRT, so it will become gamma times nRT divided by n. So from this part, we can say velocity of sound may depend upon these different factors according to this relation. So first question will be, factors affecting velocity of sound. So first expression we have pressure. So if you have to define for pressure, just check whether this particular process is isothermal or whether it is non-isothermal. So for isothermal process, pressure by density will be constant. It means velocity will be independent of pressure in this case. Let me define you pi. According to formula, PV is equals to constant for isothermal process. You may convert this volume according to concept of density. Density is equals to mass by volume. So volume is equals to mass by density. So it will become mass divided by density is equals to constant. Move this mass to right side. So you're left with P divided by rho is equals to another constant. So we can say, since the ratio of P and rho is constant for constant temperature, so velocity will be independent of pressure. But for non-isothermal part, velocity is directly proportional to root under P. Next, we may define on this dependency of density, it is inversely proportional, and for temperature, it is directly proportional. Suppose for air, moist air and dry air, density of dry air is more as compared to density of moist air, and according to the formula, velocity is inversely proportional to density. So we can say velocity of sound in moist air will be greater than velocity of sound in dry air. And one more last part, how it is related with temperature. So we'll say it is directly proportional to root under T. This is first part, this is second part, and this is third one. Iba, any doubt?
No, sir.
Okay, just write it down.